Okay, sorry for the slow pace now compared to Sean. uh, so we covered a lot of frame topics. I don't know, did you guys cover executive today, this morning? Did you go through executive slides? No? Yes? No? Okay. Uh, so we covered a lot of topics, but one thing that we didn't cover till now is migration. So you had scale lecture, right? And you saw when you have to change your struct or something in some way that is not backward compatible, you have to migrate your storage. Uh, so I'll recap a little so everybody's on the same page. Yeah, by the end of this lecture, you will know how to do these runtime migration, different strategies you can take to do these migrations, and also some nice cool ways to test your changes against the production data. Okay, when is a migration required? Whenever you update your code, we call it runtime upgrade. Does that mean you will also have to migrate storage? Maybe, right? So it depends on if you have changed your storage layout, right? And we'll go through a few examples. Uh, is this a storage migration? Just shout yes, no, whatever. Yes? Yeah. So even this value fits here, and the problem is it will not have enough data to fill the buffer, right? So this is your original, does these two would need a migration? Yes, no? Will this need a migration? No? Anybody? Yes? We will need. What about this? So the thing that you need to understand is even if you can interpret it as some data, it might not be the correct data, right? You're changing U32 to U16, U16. That's not right. And this is a signed integer. So you will have some 2's complement of a negative number. So you will interpret wrong number. Is that me? No, it's them. What about this? No. Yes? Yes. So this is 64 bytes, 64 bits, 8 bytes. This is now 12 bytes. You will not be able to even decode this into this. What about this? No? Huh? Yeah, phantom data is like a unit type. So you will not need any migration here. What about this? This is tricky. Yes? How many yes? Few yes. How many no? You will not need migration. Remember how enum is encoded? You first say the variant and then the actual value. So this will perfectly decode into this as long as you are not initializing any new C value, right? So everything works and only the new variants can. Okay. So only the new variants that you are storing, if if no old data needs to be changed, it's all fine. This is backward compatible. I can take a break. What about this? Should you ever do this? This is really bad. I mean, you should never do this. I don't know what use case you have that you will have to ever do like this. But basically, this now changes the encoding. So B was supposed to be 01. It changes to 02, and then you will have to migrate everything. Yeah, explains the same thing about enum. We talked about all the values now. What if we have to change the keys? So from foo value, it becomes bar value. Does it need migration? No? Did you guys learn how the keys are generated? So it generates key by palette name, then the storage name, right? So now the storage name has changed. So the keys where the values are stored needs to be changed, right? You need to read the value from the old key, put it under the new key, right? So this does need migration, but there is something clever you can do. Uh, there is a macro where you can say, I don't care about this name, and just have this prefix as foo value, the old name. So in your code, you change the value, but the macros that are generated will read the key as foo value. Okay, so we know when we need to write migration. We will see some examples in the code. Now you guys know a lot of code, so I want to stop or have less theory and more actual code in Polkadot SDK. Okay, few small things before I go there. Uh, imagine you are doing a code upgrade and you have to update the storage. When should you do this? You remember the hooks? There was on initialize, then there was some extrinsics that are processed, then there is on finalize. When should you do this migration of data? On finalize? But imagine on initialize touches some storage items that needs to be migrated. Will that work? So code is migrated, code is updated whenever in a transaction. From the next block, the new code is used, right? But when the new code is used, you need to have your storage upgraded, right? And on initialize could actually read a storage item that needs to be migrated. And you can break your chain.
So the block in which a state is being updated, the new state doesn't apply there. That will apply from the
Next block, yes.
So does it, even if I do at the finalize, I'm just updating the state in the finalize, how will that affect?
So,
yeah.
So migration is not a extrinsic, right? And the migration is also part of the code in a way. And the code gets activated only in the next block. So you cannot do it in the last block in on finalize.
Okay, so that migration code needs to be available, you mean? Okay, got it. Thank you.
So we need a hook that is called even before on initialize or any transaction. And I guess you have seen this already. Have you seen this? So these are the hooks that we have. There is something called on runtime upgrade, which is run before on initialize. Then we process inherents, extrinsics. Finally, if we have some weight left, we do on idle, and then finally on finalize. And what we want to do is finish our storage migration here before on initialize. Okay, let's look at an example. So this is example from nomination pool. This is a real example, and I will show you how the migration was done. We had something called reward pool. We had three fields in that. And at some point, we had some concept of commission in a pool. So operator who are managing the pool can get some commission. And so we needed to add two new fields to it. This is a migration, clear migration, right? How should we do this? So I'll go through the code. So this is nomination pool. This is a kind of not very common pattern that every palette you will see there is a migration.rs file. This is where all the migration script is. What you do, so this particular example is old reward pool. Okay, think about how should we do the migration. We have this on runtime upgrade. This was our hook. There is something, it's checking something like current storage version and on-chain storage version. Can you guess why it's doing that? Exactly. So we need some kind of versioning to know that do we need to run the migration or not. Imagine you put this script and forgot to remove it. Every time you upgrade the code, it will run again. So you need some kind of guard to make sure the code is run only once. So we store something called storage version. People have already seen this, right? Just another value, like it's just a storage value. It's a macro that is doing this. It versions your current data state. You put this on top of a palette and that's all. It does everything itself. Then what you do, you check what is the current, the code's storage version, what is stored in on-chain. And then you make sure that if current is 5 and on-chain is 4, so we are going from 4 to 5, only then execute this. And what it is doing, we get this nice translate function from storage map. We convert old reward pool. So we read this old reward pool. We translate it somehow and return an option of the new value. You can check this code by yourself when you want to in depth. But what it is doing just takes the old value, return an option of the new value. This is all provided by the macro. So once you have the storage version here, you will get this automatically. So this is an old migration that I'm showing you. At some point, the storage version would be 5. If you see, there are more new storage versions, and I will tell you why I'm looking at the old one and not the new one. But when this migration was run, the storage version would have been 5. And now since it is 8, whenever there is an upgrade, this condition will fail. And it will never run again. This code is always on chain, but it will not run anymore. Right. So internally, when you define this thing, this macro, what it does, it creates a storage value. You don't need to care how it is stored, but it's a storage value that is just a number. So you have already seen these kind of storage items, right? Imagine there is a storage value item here. And some number here. That's all it is doing by itself.
So it checks the specific instance of the runtime to see what number is in it, and then that's the current storage number.
So the current storage version is coming from the code, and you update it every time you update your code. So whenever you want to run a migration, you update it to 9, then to 10. So this is coming from code, the current storage version.
Okay.
And this is coming from the state,
Okay.
from the database.
Okay. So the current storage version is the number that shows the O,
Yes.
O number. But we want to migrate 9 from 9
This
to
number.
10, so we should put this to 9, right?
If so, right now the storage version is 8. If we want to go to 9, what we will do is bump it to 9, and our code would be like this: current is 9, and on chain is 8. And once we do the migration, I don't know if you can, if it shows. No, it doesn't. Oh yeah, this thing. So once you call this, it updates the on-chain storage item. So now it will become 9 in the on-chain as well. Okay, it's simple. You do something, you do the migration, update the version.
Does it have to be consecutive only?
I mean, you can write some weird migration if you want to, but generally you do one migration, then another, then.
Try using this one.
Yeah. So once you define this, who will call this? So I was hoping you guys already covered executive, but I will cover a little bit of executive now. It's okay. No worries. So if you look, has anybody looked into the runtime, what it does? My HDMI cable got moved a little and now it's hanged. Should switch on this. Does it work? Yes? Yeah. I did press. Yeah. Okay, what happened? Is this visible? Yeah. In your assignment template, as well as I think, yeah, in your assignment template, you should also see this pub tab executive. This basically is like what orchestrates your palettes. It calls all the hooks. It knows when to call some hooks, or yeah, it handles everything. Uh, and what does it takes? It takes few things, but at the end there is a tuple that is of type on runtime upgrade. So any palette that needs to upgrade itself, they write the script and then they put something in migrations. And you can define as many as you want. Everything will be run in sequence, and only then we will go to the on initialize hook. Again, look at the executive code if you want to. It's amazing. It's very it gives you an understanding how things work in frame. What is the flow of on the hooks, like on initialize, then you have extensions that are applied. Everything you will get the life cycle of what's happening inside your runtime. But if I have to upgrade my palette nomination pool, I will do something like this. So I defined my script. I will say palette nomination pools, something, some version. I guess it was v5, and I will say these are just structs. It already actually finds it. So you see, we defined a struct, and on that we implemented this on runtime upgrade. Any questions? And imagine if you leave this code for the next runtime upgrade. Because of the guard, it will never execute again. Okay. So we saw migration strategy where we migrated bunch of things in one block, right? And we wrote the thing inside a palette. You could actually also write this on runtime level. So you could define a struct here, pub struct my migration. You can say impl and then you can define the hooks, add it to the migrations, and it will work from the top level as well. This is useful when you have to sometimes coordinate between palettes, or maybe you're using an external palette as dependency and you don't have the control over palette. So you can write a top level migration. It's just a detail, but it's exactly same thing what you did from inside the palette.
I have a question.
Yeah.
So if there is a palette that have performed multiple migrations, for example, from 2 to 3, from 3 to 4.
Yes.
So both of the migration should stay in here for a long time, right? Because people have different nodes version. They need to do it, or just every time
So
use it and remove it.
So all the migration will happen in one release. So imagine you were doing nomination pool V9 and V10, you put both of them in sequence. V10 will never execute before V9 because of the guard that we put. First V9 will execute, then V10 will execute, and your final storage version would be 10.
We have the if current version something.
Yes, exactly. So your current version, you'd bump it to 9, right? Because right now it's 8. it will go to 9. It will check, okay, for your ninth migration script, you will say on-chain version should be 8 and current storage version should be 9. You execute that. The other script would be different, would be saying on-chain should be 9 and current should be 10 only. Then, okay, yeah, I get what you're saying though. Yes. The storage version, you are saying what you will update it to, right? Did I get your question correctly?
Yes. So my question is, shall we place the migration code here for some time, or just use for release and then delete it?
Yeah. I guess the best way would be to just do it in one migration, because if you're releasing only once, it kind of doesn't make sense to make two. But I guess there could be a reason why you have two. And what you could do is do one at a time. I think that's the safest approach to do. One at a time. Once it's done, remove it, then do the second one. But I mean, you could do other things. So you could, so you have these guards, right, that I showed you. You could play with these cards. You can say current equal to 6 and on-chain equal to 4, then do this. And when on-chain current equal to 6 and on-chain equal to 5, then do something else. So you could change this to like do whatever specific you want to do. So it's possible. But I guess the safest would be to do one at a time. Okay. Okay, moving on. There are places where we do some kind of lazy migration. Can you imagine what would be a lazy migration? So I could actually show you an example where we are doing this, if you want to later look at it. We used to have a storage where we are saving a lot of staking election data, and we save historical data. So we at any time save like last 84 election data. So if we have to migrate that storage, we will have to do a huge migration, which is difficult to do it in one block. So what we did is, there was era stakers and era stakers. Yeah, this was the old storage, and then there is a new storage that I showed you, era stakers page. What we did was, at any point there is a read to era stakers. We check first era stakers. If it's not there, we check era stakers page, or the other way, whichever you want to. And any new exposure information goes to the new storage. Old one stays, it's never updated, and eventually all the data is stale and you can remove the old storage. So the idea is incremental migrations. You migrate while you read something, you leave it as it is if it is not touched. There are other ways also, like you could create a permissionless extrinsic where you allow a bot to migrate some keys, and at some point it will be all done, and then you can remove the code. It's up to you. I mean, in your code, you can keep some kind of counter to make sure when the storage is completely migrated, and then you can remove it. But this has its own complexities. I mean, a lot of user taps, applications on top of your chain depends on the storage item directly. So it might be confusing which storage item to look at. So till now I showed you all the, so not this one, but the first that I showed you was one block migration. But there are times when the storage, there are like a lot of storage keys that we have to iterate over and migrate it to something new. Imagine a balance migration, right? You have so many millions of accounts and you have to iterate over all of them in one block, which is I think there was a time when we did some kind of migration on Polkadot. I've only heard it from Kian, where it took 1 hour to create the next block because they had to, they did something wrong with the account data. If you remember in the workshop that we did for Polkadot RPC, JSON RPC, and they did some encoding error in the migration, and they had to revert back, and it took 1 hour of iteration. So there is something called a new feature called multi-block migration that is in work. I think it's already done, but it's waiting for audit. You can actually read more about it, but the basic idea is you define a step migration. So you define one work that can be done in one block, and every extrinsic is kind of paused while this migration is going on. Nothing will happen in the chain except migration. So for, let's say, once your code is updated for 10 blocks, only migration will happen. And from the 11th block, extrinsics will resume operation. Okay, so you wrote your migration and you tested on your own test cases, but you, even if you have worked with Web2, you might have this experience that production data is very different from your test data, and you might get into weird bugs if you didn't test it against your production data. Do you think is it possible to test your changes against production data somehow? So there is a way, and there's this nice tool. Try Runtime CLI. You can again look it up. There's really good documentation about it. It uses something called remote externalities. You already know test externalities, right? Remote externalities, what it does, it connects to a RPC node, get all the keys that you want to test against. So imagine you want to upgrade your palette balances, some storage item in that. What you can do is you can say from this RPC node, get all the keys that are there for this palette. Or if you want, you can get all the keys in the whole state, every palette. And then run your migration against that state. We call it remote externalities, but it's basically test externalities filled with the blockchain state at some block. Just to recall how everything works, you have host functions that the runtime uses to talk to the node, to the externalities. You have runtime APIs that host uses to talk to the runtime. Remember, validate, pool, apply extrinsic, stuff like that. And we used to call that externalities. And in your test, you use test externalities. So we will use exactly things that you have already used. We will connect to a RPC node. We will say which palette keys we want to know. We will run this, and this will basically load your test externalities with all the data from whatever RPC node blockchain this is. And I think you can define also at which block you want to do this. I can show you also code just so this makes sense. So here is one test. We have this pallet bags list, which does a lot of tracking of stake for all the nominators and validators. And they must have written some kind of new API and want to make sure that when they regenerate this, it works with the new, like everything that they assume the state should uh, uh, let's go through the code. So we connected to some URL. So there's a try runtime CLI that you can pass all these variables. Okay, let's actually do it at this. Yeah. I guess this is like the most important link for anybody working with substrate chains. You can always open this and look at all the things that Parity releases. There's this try runtime CLI. And you could use this to build your remote externality. You save some RPC address from which it should load the keys. You call some hook, and I didn't show you something, but I can show you now. That this on runtime upgrade also had this something called pre-upgrade and post-upgrade. Can you imagine what that would be? So this CLI, what it helps you to do, I'll just, it can load your remote externalities. It will check some state that you want to assert on before you do the migration. Do the actual migration on runtime upgrade and call some functions once you have upgraded to make sure things that you assume should be right. You do some assertions that everything is still like makes sense in your state. So to recap what you're doing, you are downloading state from a production blockchain. You're asserting some state before you do the upgrade. You upgrade your code, and then you do some more asserts to make sure everything still makes sense.
So this is all happening like within like an overlay or some sort of like how is this?
So this is like your unit test in a way. What it does, it fills your test externalities with the actual data that the production has, but it's an in-memory database. There is no overlay or no client, no real client. Yeah, to rephrase it back, we are running unit test with production data. Imagine if you are writing test, you would be setting up, right? You will set up some case and then you will write your unit test on that, right? Here we are doing the exact same thing, but the data is now from remote blockchain. It's very cool. Actually, I'm not going to do the demo, but if you look at this try runtime CLI, there are some YouTube links and Crowdcast links, and you can see like a full demo of how this works. It's very cool. Like you should never do a runtime upgrade before running this tool. It actually also outputs how much weight you consumed for your migration. So if you're a parachain, you have some limits on how much time you can execute and how much can be the proof size, how many storage keys you can touch. So this tool actually gives you a number of weight, so you know that you will not break your chain. Okay, let's see what's left.
I have a question. I remember that in the hook class, there is tri-state hook.
Yep.
It also, if I don't remember it wrong, it also used to try runtime or test whatever. I'm not sure. What does that do?
Yes. Let me go to the documentation. So what it says that when you are okay, so you saw this tri-state hook, right? And sometimes you want to make sure that imagine you have two storage and you want to make sure the count in this storage and the count in that other storage somehow should be equal, or you have some kind of invariance that you want to make sure at every okay, let's take the example of frameless exercise. We said that at end of a dispatch every account should be in a valid state, either destroyed or above existential deposit, right? So you could write a state, a test basically, something called tri-state, where you say, you iterate over all the accounts and say every account either is, not either, account will not exist, which is fine, or if it exists, it should have a balance more than existential deposit. So you write this function, and what you can do, you can use this try runtime CLI, you can execute a particular block, or you can actually, there is a thing called follow chain. You can follow the chain, and while you are following the chain, you can execute this try state after every block. What that means, after every block, you are checking the state of your blockchain and checking this condition is always true, that no account is an invalid state. Does that make sense? So you are basically writing a production all the time, like some monitoring test that makes sure all your invariants that you have in your palette is always true.
So this tri-state, is this in the production environment for every block, or just we do the testing?
So I'll show you the code. So if you see, this try-state function is feature gated with something called try runtime. So this is a STD enabled, STD only enabled feature, which means this is something that is not part of your WASM, but a node provider, or if you have your own chain, you can run this. I don't know if it's actually there. We wanted to build this, but one idea is to run a node. Like you are running your own node with tri-state mode, where every time a block is created, you're also doing these tests. But this can be expensive. So if you see a lot of our tests, it iterates over a lot of storage items. So it could be very slow. So you don't really want all the node providers to run this, but it's something like a monitoring tool. You could have this in CI. So whenever you make a code change and you want to merge, you make sure your new code, after it's upgraded, the tri-state is still like all the invariants or assertions in your code is still maintained. Does that make sense? Okay. I feel a bit of tiredness in the group, so okay. So I told you about this remote externalities. This try runtime CLI fills this externality with this on-chain production data. It has a lot of like custom features that you can do. You can upgrade the code and do something. We already saw that with the tri-state thing. Yeah, you can choose what keys to read. You can choose only to read some child tree. You can choose to read only a palette. So yeah, you can just go through the documentation and see what it can do for you. Yeah, you already saw this execute block that we saw in the runtime CLI example. You can actually go back in time, say at this block, run this try-state. And whichever state, so you load any state and you can run your whatever test you want to run. So you want to say at this Genesis block, my state should have been this. You can run have a test like that. It might not, if it doesn't make too much sense right now, it's okay. If the first time you will start doing migration in your chain, just remember something called tri-state. Look at the documentation again and see what it can do for you. Yeah, we covered this. So, yeah, I covered everything that I needed to cover, but I would really recommend if you are interested in this, how migration is done, read this try runtime CLI. It used to be part of the Polkadot SDK, but now it's actually lives outside it. There are really nice demo videos as well. I could send one more video actually. There was a recent demo given by a Parity employee. If you search try runtime Liam, yeah, this was very recent. I think 4 months ago. You can see this, and this guy will show you how you can use the try runtime CLI.